All right, so here we are. This short video is going to be all about the pH scale and hydrogen ions. So how do they get the pH scale of 0 to 14 based off of the amount of hydrogen ions? Okay, so let's first just talk about a couple definitions. I'm going to alternate colors just because it sounds like a fun idea. So when we talk about pH, it's usually referred to as a measure of hydrogen concentration. That's what pH tells us. It's a measure of hydrogen concentration. In fact, sometimes you'll see pH as the power P of hydrogen. Power of hydrogen, pH. Okay, so it's really a measure of the amount of hydrogen ions. Now, more specifically, it's the amount of hydrogens in a solution, and that's why you'll see brackets. So when we see those brackets around the hydrogen, it's telling us that we're referring to not only the amount of hydrogen. I'm not sure why I added an S there. Let's try that again. We're not just talking about the amount of hydrogen, period, but we're talking about the amount of hydrogen in a solution. So the brackets tell us we're talking about the amount of hydrogen, apparently I can't think of anything right, in a solution. All right, so if we talk about this, pH, that pH scale of 0 to 14. So we know the pH scale goes from 0 to 14. So pH is representing a logarithmic relationship between hydrogen in a solution and this pH scale. So let's talk about this next. So if we were to give a formula, we would say that pH is equal to the negative log of hydrogen in a solution. So what on earth does that mean? So first of all, this is a logarithmic relationship. Let's just first mention what that is. Logarithmic just means that each successive change in one pH unit is equal to a tenfold change in in hydrogen ions. Concentration, I should say. So what that tells us is every time we change a pH unit, so the pH scale goes from 0 to 14. So what if we go from a pH of 7 to 8, or a pH of 6 to 7? Each 1 unit change in pH, is equal to a tenfold change in hydrogen concentration. So that's what the logarithmic is telling us. So now let's talk about how these values would be at neutral, and then acidic and basic. So if we go at neutral, so we're just going to say a pH of 7. So let me go a little bit higher here to save space. At a pH of 7, which is neutral. I mean, our blood is about 7.35, 7.45, 7.4. But if we just go right in the middle of the pH scale, at a pH of 7, the amount of hydrogen concentration in a solution is equal to 10 to the negative 7 power. If you put that into a calculator, if you put negative log 1 times 10 to the negative 7, you get 7. So that's where it comes from. But let's just start with, at a pH of 7, the amount of hydrogen concentration in a solution is equal to 10 to the negative 7. So however many hydrogen ions that is in a solution, that's what we're considering neutral. How does it change if we go acidic or basic? So let's give an example of acidic. So we know that when something is acidic, it is represented at the lower end of the pH scale, and it is a solution that has a lot of hydrogen ions. So it's represented on the lower end of the pH scale, and that solution contains a lot of hydrogen ions. This is what it might look like. It might look like, let's do a pH of 7, right? So at a pH of 7, oh, excuse me, that was your example for the neutral. Let's talk about something that's acidic. Let's talk about something like hydrochloric acid in the stomach, right? So at a pH of 2, the amount of hydrogen ions in that solution is equal to 10 to the negative 2. So when we have more hydrogen, this value, when we have more hydrogen, this value is less negative. Compared to our neutral, right? Neutral, we had a hydrogen concentration equal to 10 to the negative 7. So if this is our starting point, 10 to the negative 7, then when something is acidic, if we go from, oh, it's hard to see. If we go from 10 to the negative 7 to 10 to the negative 2, it's less negative. We're going from negative 7, negative 6. We're trending in the positive direction, which means that there's more hydrogen present. Because compared to our neutral, it's less negative. It's less negative because we have more hydrogen. Versus if we have something that's basic or alkaline. The basic is represented at the higher end of the pH scale, and it is on that higher end of the pH scale because there's less hydrogen ions. So now our example might be a pH of 12. It's pretty high. At a pH of 12, our hydrogen concentration in a solution will be equal to 10 to the negative 12. So now, again, compared to our baseline at neutral where we had 10 to the negative 7, now we've become more negative. Now we're negative 12. And since we've become more negative, the reason we've become more negative is because there's less hydrogen. Hydrogen is a positively charged ion. So compared to baseline, our pH scale, we go higher, 10 to the negative 12, because there's less hydrogen. So from baseline, negative 7, now we go to negative 12. We've gone further negative on the scale, which means there's less positive ions or less hydrogen ions. All right, folks, there you go. Good job.